to our, hello, I always do this. Okay. Welcome to our ChicagoRuby June meetup. As a reminder, we aim to meet every first Wednesday of the month. We want to thank Chime for letting us use their lovely space and for being such a gracious host. With that, I'm actually gonna move on to the next slide. All right. On behalf of all the ChicagoRuby organizers, myself, Anton, Dan, Josh, Jonathan, we just want to thank you for joining us all today. All right. Okay. Some quick housekeeping and announcements before we get officially started. First, join us for our future events. We will post our events on meetup.com as well as on Slack. All right. Speaking of Slack, we have our own channel within the Ruby Central Community Slack, hashtag ChicagoRuby, as well as the hashtag Ruby channel within Chicago Tech Slack. These Slack channels will be a place for us to connect, as well as where ChicagoRuby organizers, such as myself, will post any announcements prior to our events. We've created QR codes for invitations to the Slack channels I mentioned. Reach out to me if you need an invite to any of those Slack channels. Okay. Missed a previous event or want to rewatch a talk? We have all our 2025 and onward events, event recordings posted on our YouTube channel at Chicago Ruby Meetups. Feel free to give our channel a subscribe and our videos a like. Right. Okay. Interested in hosting? Chicago Ruby is on the lookout for organizations willing to host our monthly meetings. If interested, reach out to Anton, who's our location recruiter. All right. Okay. Interested in speaking? We would love to hear from you. Feel free to reach out to me for more info on speaking at Chicago Ruby. If you're interested in speaking but aren't sure what topic to choose, or if there's a topic you'd like to see covered, we've put together a list of potential topics that members of the community are eager to learn more about. That QR code right up there will send you to that list. Feel free to add your ideas on that Google spreadsheet. Okay. Chicago Ruby is proudly supported by GoTo Inc. GoTo Inc. is a UX, UI, and engineering talent as a service provider for Ruby-powered organizations. We're incredibly grateful for the support GoTo Inc. has given for to our community. If you'd like to learn more about what they do, be sure to connect with Anton, who's in attendance today. If you're interested in Chicago Ruby, either by hosting a different type of event, like a hack night, code and coffee, collaboration with other groups, or through a sponsorship, we are super down. Reach out to me for more info on sponsorships and hosting events. Okay, new slide. Prairie Postgres, a separate group, is hosting PG Data Conference, the first one, tomorrow, June 4th, as well as June 5th, at Loyola University Water Tower campus. You can register on their website, 2026.pgdata.org. Yeah, I'll be there. Hope to see you all there. Okay. Last one. Join us next month in July. Alan Reidelhoover will be speaking remotely and giving us a sneak preview of his RubyConf talk, Indispensable. I think he's here remotely, as well as Tony Juncker. He will be speaking, or he will be here in person talking about testing read-only models. We will be at Ninja Holdings July 1st, 6 to 8:30. Okay, yeah. With that, I'm going to hand off the mic to Ifat. And I'm also going to stop sharing my screen. For a hand, yay! This or yeah. You want a lapel?
In progress.
Thank you. Yeah, beautiful. All right, 1 second. Almost ready. Wait, I am not joining the audio, right? Oh, Anton? Yeah. Not joining the audio. Okay. Leave that alone. All right. I guess when I share, it'll come up there, right? Yes. Okay. All right. I'm tracking. Okay. I'm not nervous. You're nervous. All right.
I'm nervous.
What's that?
Yeah.
What
Oh,
else?
no, I'm here to help.
Oh, okay. I think I'm good. I think I'm just gonna share, right?
Yes.
All right. All right. Everyone can read that. See that okay? Beautiful. All right. Hi, everyone. Welcome to, yes, this edition of Chicago Ruby. Really happy to be here. Really happy to be back at Chime. I've spoken here before. Really love being here. My name is Ifat Ribon. I work at LaunchPad Lab. We are a small digital agency headquartered out of Chicago, but fully distributed across North and South America now. And this talk is about testing, particularly in the age of AI. And so there's probably going to be some things in here that maybe you all are familiar with or have thought about before, but I wanted to talk about how to reinforce those concepts, especially when you have AI at your disposal. Hot topic, obviously, for everybody. So how many people are able to use AI really regularly in their day at work or hobby coding? Everybody, pretty much, yeah. Just making sure. There are some clients and teams out there that, are still a little, they're waiting on it, but that's all right. So you've probably seen, I'm sure you guys are using AI to generate tests, because probably generating tests is, if you're anything like me, probably your least favorite part about coding, but you know that it's important. And you've probably seen how fast AI can generate tests. And if you're anything like me, you're like, that's incredible. My least favorite part just got sped up. I now have better test coverage than I've ever had before, right? Maybe. All that test coverage isn't really free though, is it? Gives you more to review, gives you more to reason about, think about, more to maintain over time as that test suite grows and grows and grows, more to run in CI, which is actual compute power, more tokens for the AI to write all those tests, right? And run those and check those out for you. So AI can do things fast. It also likes to do things more. Let's take a step back. Well, why are we even writing tests to begin with? And bear with me. I hope that this part isn't particularly new, but I think it's worth reiterating. One, we want to validate that the code that we write meets requirements. Much like AI generating test code quickly, I'm sure you all know it's generating app code very quickly. And maybe you all are feeling like me, the amount of times that it's been almost hard to keep up with that. Luckily, tests can help validate the code, but if the code's just validating the code, we want to make sure that the code that's validating the code that needs to be validated is also good. We want to protect those essential user flows in business logic, right? So not all of our code is created equal or necessarily holds equal weight in the app, right? There are certain things that we may be willing to shrug off a bit, and there's certain things that we absolutely cannot have happen, right? Think security incidents and things like that, right? Protecting our users and their data and their privacy. So we want to hone in on what's most critical. We want to be able to catch those key failure states and also interdependencies, right? So I'm sure a lot of your systems have a lot of pieces working together. Even within a Rails monolith, I'm sure there's a lot of boundaries and entry points and interfaces going on. So we do want to make sure that all those hands-off and edges to our code are working well together. And ultimately, we want to be able to enable refactoring with confidence. My favorite part about coding is I might have written something 6 months ago, fast forward, and I'm like, why would I ever write it like that? What if I wrote it this cool new way that I learned, or I've evolved, or someone taught me something? So this ability to refactor, to pay down tech debt, and things like that, if you have a really strong test suite, obviously that makes it a lot easier. You know that your code is still behaving the way that you want to, even though you may have changed some details. Now, there's a lot of questions out there about what is good test coverage. And that's kind of what comes to a head with AI with all those extra tests. Good test coverage, in my opinion, is test coverage that gives you enough confidence to achieve all of these requirements, that the code works as expected, while staying maintainable, while avoiding all the mores we saw a minute ago, right? If your test code just gets bloated, you're not sure what you're testing anymore, you may have introduced new tech debt into those tests. You're not really sure if you're able to, if you really are protecting essential users' flows, if what you're refactoring is even the thing that's being tested anymore, right? So it's just as important to maintain your test suite as it is your actual app code. So I want to introduce some testing principles. Again, these are things that there's a lot of articles, a lot of content out there. It's kind of my packaging of it. The first one, we'll go into each one, but the first one will be about the idea of testing behavior rather than implementation. Hopefully that's a familiar concept. We'll look at some examples together. You want to keep tests deterministic. This is a really, really key one for me to take away, is that if you have a test that changes based on different inputs, you probably have a smell about what's going on, whether it's in the app code or in the test design itself. You want to balance that coverage with cost. That's what we just talked about, right? So you don't need to necessarily have a line of tests for every single line of code. You want to make sure you're testing the right things. And like I alluded, your test design can also inform your code design. And that doesn't necessarily mean writing TDD or writing the test first. But like I said, if things are going awry with your tests, it could be worth looking back at your code and saying, hey, is this written the way that really makes sense and upholds those values that we set out to accomplish? So let's take a look at each of those. So in terms of testing behavior over implementation, skip testing, library code. We don't need to test for Rails apps, Rails internals or externals, right? With the first time I had AI write a bunch of tests, it wanted to test every single enum method. And I was like, we don't need that. Like Rails tested that. That's good. We're good. Don't do that. Generally speaking, people recommend focusing on public methods and their results. I'm happy to modify this. I think I've, certainly written some pretty complicated classes so that I use the private label to sort of hide that it's the internals, but maybe I had some pretty complicated logic in there that I wanted to be very certain about. So it's not an end all be all, but the idea is that you want to focus on the outcomes of your classes and your methods and your modules. And like we talked about, a test shouldn't fail just because you swapped around how you organize that code. So, we have a couple examples of these, right? You don't obviously need to test that a method or that a class responds to a method, just test that the method is doing what it's supposed to be doing. If it doesn't respond to the method, you'll know right away. Similar, right? Like not testing sort of like the deep level internals. Of course, I'm just showing the test and not showing, what the actual app code is, but I think you can kind of understand the examples here. So a good test, a really great test will survive refactors. Swap out how you get there, how you want to calculate discounted total. You want to use, all crazy sums of algebra or whatever it is. I hope you still get the right answer at the end. Keeping tests deterministic. So this was a big one. And I know that, different testing libraries in Rails help advocate for this in different ways. Minitest, for example, really advocates for keeping data local. The more local your data is, certainly helps you to reason about what's going on, but it helps you be a bit more sure that just the system under test is being tested with just the data that it needs, right? In RSpec, no knock on RSpec, I love RSpec. It tries to advocate for this, it advocates for a more dry style, which is nice, but you might be defining your variables at the top of the code, right? And then it's kind of hard to track where that data might be polluting your tests with those let statements or before statements or things like that. Other ways to keep things deterministic is to be intentional about that system under test. So if you're writing a unit test, and we'll talk about test categories, I just want to test that a class is working the way that you want it to, but it ends up calling another class. You don't need this class to test that other class. Stub that out, assert that given the results of the collaborator, your class is still doing exactly what it's supposed to be doing. You can go test that other class separately, and then you can write a more comprehensive integration test, which we'll talk about. The other big component of flaky tests, non-deterministic tests, are time. Obviously, one of the hardest things in coding for sure. I think we all know that, but luckily we have some nice libraries and DSLs to work with. So travel to or time cop or things like that. Mimic the exact time that you want to mimic. And that's really helpful for edge cases too, right? What happens when the new year starts? Or, I worked on an app that was based on the school calendar year, and it was really important when things changed between September or January or May. So keeping those times mimic exactly what I need to happen at those different points was really important. If you are having failing tests, especially flaky ones, do try rerunning it one time just to see if it's a flaky or not, because you might want to diagnose it differently. But ultimately, something's broken, either in the test design or potentially in the app itself. In terms of balancing coverage with cost, we're going to talk about the different test types that I've already kind of touched on. You can choose those intentionally. We talked about data, so just have the data available that you need. In unit tests, at least, avoid testing external dependencies, right? We can talk about when and where and how to do that in a more selective manner. But for your unit tests, again, you want to make sure that your code is working right with information that it has control over. You can stub those things out. So we have some more examples here. And lastly, around the test design itself, to inform good code design, much like the single responsibility principle that I personally very much love and adore, your test should also have a single reason to fail, especially for unit tests. System tests is where we might want to get a little bit creative with that, and we can touch on that. But you can see some examples here. If we're asserting several different things, it's really hard to tell when we're running the test what actually broke down here. You want to focus on the outcome of the code that you're testing, and the actual failure that you get should help you debug and immediately figure out what's wrong. So hopefully, none of this is super net new, maybe just a good refresher on good testing principles. So just to recap on the test categories that I alluded to, and I'm using, mostly Rails conventional semantics and kind of, again, my own flavor for naming these things, but unit tests, this is very discrete logic and isolation. This is where you're really stubbing, you're just focusing on one thing at a time. These are usually going to be your model specs, your Poro specs, things like that, and very specific edge cases you might want to tackle. When I use the word system test, I think about mostly the browser experience. So usually introducing a tool like Capybara or something like that, where you're trying to assert what the user should experience. Again, in these tests, you might want to assert multiple things because of cost. But when you do write your system tests, it's best to focus on the happy paths. And for really edge cases, for edge cases, most likely the edge case has a little bit less to do with the UX itself, and usually has more to do with the logic behind the scenes, right? Your order total is not coming out right. You're not able to filter correctly. For those edge cases, try to isolate that down into a unit test so that you can run those a lot more frequently at a cheaper cost. And lastly, end-to-end tests, or perhaps integration tests, would be how all those systems fit together. This is where you might actually make a live API call. This is where you aren't stubbing anything at all, and you actually want to test something all the way through. So those are the categories. Oops, sorry, I'm got to move this. Yeah, as I mentioned, unit tests, they're supposed to be fast, and they will be if you keep your data local, you keep it specific. System tests are going to be slower. You just have to spin up the browser or the actual rack session. And your end-to-end tests are obviously going to be the slowest. So you have probably seen this before, right? The test pyramid. Again, the idea that your tests can, as you move up the pyramid, they both increase in time and also, how expensive they are, right? And as you increase in time and cost of creating the test and running the test, you also want to, I guess in this case, kind of narrow the scope of exactly what it's going to test, right? In your system tests, that's why we don't want to test every edge case, because they're slow and expensive. Can we whittle those down a bit to just the happy paths and make sure that our pages look the way that they should look? So the way I think about these tests in my code bases is that unit tests should be frequently. A lot of times I'll just add a Git hook to just run them every time I commit, or if you really do have a large test suite, if you want to do it on pre-push or something like that, certainly you should run in CI. But if you're getting that feedback faster locally, the faster you can go fix the test, faster you can go fix your code. System tests, definitely run them in CI, and then Locally, I usually just run them if it's the exact flow that I'm working on and it's a new test or I've updated something. And then the end-to-end tests, I try to run periodically. I usually call these out in my GitHub Actions to either completely skip them on regular feature branches and only run them, dev to staging or staging to prod, right, on release. So you can be very intentional about when you're running these tests. Obviously, the slower and more expensive they are, the less you want to run them, which is why you want to be very intentional about what you're testing, when and where. Sorry. So that was a lot about stuff about good test design, which is really important to have those foundations so we can talk about how to tell AI to be a good tester, right? So the way that I've been thinking about it and using or exploring with AI, particularly in writing test suites, first and foremost, I have the AI generate all my tests. I borderline maybe forgot how to write my own tests. I'm not really sure anymore. I like having the AI generate all the tests, and that's great. That's a really good first pass. Sorry. And it's going to do a lot of them. Oh, that's a bit small. I'm sorry. I can read those out for you. So we've got a good test about core behavior, that the discounted total works correctly. We have an edge case that we don't ever want to drop below 0. Okay, we're still kind of testing the same method, but like maybe this is an edge case we care about. Well, yeah, I might want to introduce this enum one that I absolutely abhor. So we might want to tell it not to do that anymore. And it might want to try to include, I've seen this a ton of my tests generated by AI, it duplicates test cases a lot and it kind of words them just a little bit differently. But ultimately, it's just trying to see that the discounted total is the same again. We already did that, and we even caught our edge case. So in my experience, AI will overgenerate. Has that been people's experience? Like, you guys have been writing these tests, and it's just doing a whole bunch, right? All right, well, let it do that. That's fine, just to get a pulse on what it's doing. Oh, okay, all right. Yeah, sorry. So, AI is a force multiplier, but we still have to incorporate all those fundamentals that we just talked about and your own judgment from, your guys' years of experience and everything that you've seen so far. So take a close look and let's review those test cases. That's your job as a human. Like we talked about, what behavior is actually being asserted and is it even important? So there's gonna be some instances where it might be a test that's adds to your total, line coverage, but is it really that important? Like, is anything going to happen if it breaks? Maybe not. And maybe at the beginning of your test suite, that's fine. It's negligible. Test suite grows and grows and grows. These things compound. Is it going to survive the refactors? If you ask the AI to go change how you organize a class, these tests better hold up. Is it set up minimal, right? We talked about this. Is it deterministic? Or can we run it a few times to get the same result? And is it redundant with another test? And I'm kind of reiterating all these questions or all these concepts as questions because these could be really great fodder for a skill or a rule, something that you can pass off to your AI to always ask itself after it's generating these tests. And then you as a human could do it as well. The next step would be to curate your tests. This would be in collaboration. This is you actually working with the AI. We'll talk about skills and rules and things like that, and help the AI understand what are some of those good practices. Pre-AI, this is true. Tests evolve with your code base. Most of the time, I'm not just adding new tests. I'm also perhaps removing tests, ones that no longer fit the bill for the values that we already articulated. So I might refactor those tests. Maybe I noticed that we're actually putting way more data, or maybe I noticed that, it wasn't stuffing the collaborator, or it's not meeting all those other criteria that we had. Maybe the business logic changed such that we need to adjust the test and we need to refactor how it's designed so we can still have the same outcome. Keep it dry, obviously. I would say the one gray area here that I've picked on, again, with mini tests and this idea of keeping data local, you can keep it dry by extracting shared helper methods and things like that. But the idea is to create the data itself in the test. So for example, I might want to create a type of user that is in, an approved state for my app, and a user that's in an unapproved state. For each example, I want to recreate that user and have that very in line with my test. But I can certainly have shared helpers, whether it's a fixture factory or some more complicated method, to keep it dry so that you can maintain your logic. But each test itself should repeat, create the user or something like that. I try to not have sort of mass creations at the top. I also try not to update, a formally created, if I would create a user once at the top and then call update, that is another way to do that. I try not to. I try to say, what is the data that this test needs and keep it dry in other ways. And my absolute favorite thing of all time is deleting code. Delete tests. If you don't need it, if it's not important, delete it, get rid of it. You don't need it, it becomes a liability. It is tech debt. It adds to all those costs that we talked about. One really good example of this is a test that did help you out at first and you no longer need. Some interesting examples that my colleagues have shared with me are they wrote some tests for seeders because you might not want to rerun the whole seed suite every time you're working on a feature. So why don't we have a couple tests that just make sure we're creating all of our associations and records correctly. But as we gain confidence in our seeding working exactly the way we want, get rid of the tests. It's not adding value anymore to the code base. You may want to at first test that you've kind of configured things correctly, right? There's a lot of thoughts out there on whether you should test things like Rails validations and things like that. And you might say, okay, well, it's custom, it's logic that I'm defining for my app, but it's also very hardened Rails code. Maybe you write the test to start, make sure you've got your app designed the way you want, then get rid of them. If that's stable code that's not changing and it's mostly Rails internals, get rid of it. I love deleting code. Delete code. The best code is no code. So be ruthless about it, especially AI generated ones, because it wants to duplicate and it wants to add extra stuff. The next step then would be to harden. So I would say that AI has been quite good at catching some edge cases that I haven't thought about. It's one of my favorite parts about working with AI in AI assisted development, but it still misses stuff, right? It doesn't have all the context that you have and that you brought to the code base. So help the AI fill the gaps a little bit. You might hunt for missing cases, and you might turn this back around to the AI. AI does pretty good with very direct instructions, right? If you give it a very broad prompt, it's more likely to miss stuff. So go ahead, ask it again. Did these tests actually cover every edge case? What else can you think about? To that extent, what other kind of weird things can we introduce? Can we introduce what happens with stale data or incomplete data or, weird edge cases that, probably aren't likely, but could change the scenarios a bit? And prove that it catches bugs, right? Ask the AI to try to break your app, not with the test suite, but with the code, and then have the AI go generate a test out of that. So as you're doing that, as you're learning what the AI likes to do and what you would prefer that it does, go ahead and capture all of that. You can capture that as you do a PR, you can capture that locally, at whatever step you want, but the key thing is to capture it. And the way that you might do that to bolster your AI harness is, I'm sure you're all familiar, rules, skills, and agents. I'm not sold on the different terminology just yet, but my understanding is rules are where you can codify, the repeat discrete steps. You can capture the things that we talked about in this talk. These are the things that should always happen, right? The principles that we talked about. The skills then would be, all right, use those rules. Here's when to introduce the rules. We introduce a new feature. We need a test. Here's the general premise of how we go about testing. That's where you might use skills, which is more of the Claude terminology. And then the agents themselves, maybe you want to start crafting a dedicated test agent that is empowered with, a suite of rules and skills across whatever your test suite may be, right? So you might have rules dedicated to, all right, this is how we write all our mini tests. You might have rules dedicated to how we write capybara. You might even go more granular than that. But the key is that every time you see the AI take a misstep, write it down. Actually, have the AI write it down. Have it add its own rules. at LaunchPad, we have a cursor like in GitHub as well. So we just @ cursor, and every time I see a bad test, I'm like, nah, remove, update your rules. We're not doing this again, right? We don't need to test Rails internals again. Let it go. So I'm sure, a lot of you do have experience with this. I'm actually curious. I want to open up to the floor a bit. If people have, kind of spent some time with some of these harness elements, specifically for testing and how that's gone. Has anyone kind of spent time with that? Do you have any examples you're willing to share?
Usually what I've done has been along the lines of making a reusable prompt that says, here are the requirements in my plan file. First, write tests that will be expected to return red. And then after it's implemented, for each item that's implemented, run its tests and make sure it's green. If it's not green, evaluate, like, is this a false negative, or like, did you miss something when you wrote the test, or did you not implement this right? And then continue, like, rinse and repeat. So that has worked fairly well for a project that's going to scale to like millions of requests a day.
Nice. I like specifically what you added there in that TDD flow of having it do it very incrementally, and then also have it ask, what exactly is breaking down. I found that when I'm debugging tests, I generally suggest that if it thinks the app code needs to change, it better ask, because it may be a bug totally, and the test was actually catching that. A lot of times it's not, and usually the test design isn't quite where I wanted it. But thank you.
So what I did was I had a rule that said adhere to red-green refactoring whenever you can. And then I also vibe coded a script that would actually verify that. Nice. Run the new tests under the old code, assert that it is an assertion failure, not like a no method error, not an unexpected error, but like an actual assertion failure. Then run the new code under the new tests, assert that it passes, and it'll give a report out for the LLM where it can say, hey, this thing, passed, but it passed trivially, so, it doesn't pass. And so by doing that sort of thing, that actually tightened it up quite a bit. I got much better results from the coding agent after doing that.
Nice. Yeah, thank you. That's awesome. That's a really good way to do that and have it kind of test that mutability that you introduced. Yeah, anyone else want to share their experiences or things they've tried? Cool. All right. Well, I'm always happy to talk more about this. That was the end of my talk. This slide, actually all the slides were AI generated, so thank you. Oh, I guess I didn't mean to stop sharing. Does anyone have questions for me, I should say?
I was just wondering if, based on your experience, you've seen any more difficulties or an increased cognitive debt with the challenges that come with hardening the AI tests. As you mentioned, AI naturally generates a lot of tests, and in my experience, from what I've seen, and by the way, I use AI all the time, but from what I've seen, it generates tests that shouldn't be there sometimes. Does that, in your experience, add to the complexity of the task that you're working on? And how do you navigate that?
Yeah, so I think the question you're asking is, as we've seen this increase in generated tests, how has that kind of maybe affected how, how complex my work is and how I've dealt with that? Is that right?
Let's say it's a prehistoric one's difficulty task. Now with the addition of working and hardening the task, this is additional complexity that's been added that wasn't there.
Yeah. Oh, you mean just like in general having to like iterate and harden? Yeah, that's a good question, and it's definitely, I've certainly experienced this. It's like I could just blow through this feature and try to get it done, or I could try to like make this update to the AI such that I'm not having this continuous problem. And I'm not sure that that's totally a net new problem. I'm sure there's been a lot of instances before AI where you're like, I could do this a little bit faster this way now, take the time now, help me later, or I could just blow through. So it kind of feels like that for me. And I think the biggest thing that's helped is finding making those incremental moments part of my workflow. So I mentioned we use the @cursor user in GitHub. That's been really helpful because when I'm scanning my own PRs before I hand it off to review, I'm already in a different headspace, and it's really quick for me to stay there. The problem is then it goes, into the PR, and then I have to bring it back down. So I think by similar fashion, if you're working locally, maybe tag it on to the end of your prompt. I'm working on a feature, write tests. If you're not adhering to my rules, maybe you already have 4 rules. If you're not adhering to my rules, add the new rule. So incorporating into your prompts early and often, and finding just places to inject it in your workflow. I know that wasn't the most novel answer, but I guess that's kind of what I've been doing. Yeah. Any other questions for me? Yes.
Have you noticed, with projects you're working on, a significant cost increase for the testing that prompted you to kind of go through this presentation to try to get people to reduce those tests? And has it increased with AI, or has that been an issue that you found? And are there other ways to fix that issue without having to do all the hardening and other things like that? Or have you mostly been focused on reducing the number of tests, reducing the scope of the tests, deleting old tests, that kind of thing?
So the question is, if and how I've seen an increase in cost due to AI being involved in testing.
Infra costs like CI, you mentioned that, right? That's kind of where a lot of the cost lies.
Yeah.
Some tech debt, but mostly the infra and stuff.
And there was a second half to your question.
Is the focus mostly been hardening, and cleaning up the test suite, or is there some other solution to now having more tests that are cheap to generate that can somehow maybe be cheaper to execute as well?
Okay, the second half is interesting for sure. The first half is, I would say anecdotally, I've seen an increase in cost. I don't get to review all of our CI bills at my company, but I know that our number of tests have increased, and our number of, our minutes spent on those GitHub actions have increased. So ostensibly, I would think the costs increased. By how much, I don't have a number, but.
Waiting for the test to finish is still a cost.
So that's what I was going to say. There's, thank you for reminding me. So there's a cost of the CI. There's a cost of the tokens themselves, which I added to my Claude status to tell me exactly how much it was running up, which is helpful for me to know. And there's the mental cost. I think something I've experienced for sure is review fatigue, 100%. Mental cost of looking at those tests, mental cost of having a PR that all of a sudden has way more letters to look at, and things like that. I would say that for sure has increased. As for strategies to combat that aren't hardening, I suppose you could write the test yourself and use all the principles that we talked about. It's a very good question. I have found that the AI agents, the models that I've been using natively, haven't been able to incorporate these principles very well. And so I've had to add these things. But yeah, I'm curious if you had ideas you were thinking about, or just curious. Yeah.
So your talk was about using AI to generate tests and help with that whole process. And there was human review is definitely a part of that. But do you foresee investing in using AI to generate tests as a way to possibly remove the human from the review process of app code or AI generated app code?
Oh, I feel like this is the big loaded question, right? Do we remove the human in the loop? I don't know that I'm personally ready for that. There's a lot of opinions out there. I would say, though, to your question, or maybe what I'm kind of hearing underneath that question is, with the ability to generate more tests, do we feel more confident that we can reduce human review? I would say that generally that is the goal of tests anyway, right? Is to build that confidence in your app code. I think the shift now is or what you're asking about is, well, do I not even have to review the app code that I didn't write because the AI wrote it and then the AI is writing the test? This still makes me a little bit nervous. I have a strong aversion to a system testing itself kind of thing. So I don't know. I think that I'm not ready for that. Maybe one day we'll feel more comfortable with that.
Cool, thanks.
Yeah. Okay. Might have one more right there.
We're close
All
to
right,
time.
last question.
All right. So we've written tests to verify that the code works as intended, but testing has a different purpose as well, documentation. How good, in your experience, have the LLMs been at reading tests that other LLMs wrote in the past?
Ooh, that's a very good question. I don't know that I've ever intentionally set it off to read tests as a way to understand more of the code base, but I've definitely caught it reading more of the test suite to introduce new tests or to refactor existing tests to say, was this covered or what was the style we did? So I think I've seen it happen sort of organically, but I don't know that I've actually prompted it to do so more intentionally like you're suggesting. But cool. Thank you so much, everyone, for the time. I really appreciate it.
We're gonna take a 5-minute break before, while Vito gets set up.
Thank you very much.
All right. Have some pizza, some fruit, some veggies. Take more fruit. I don't want to take it home. If you could, like, and his camera, because I think he'll have his camera on. All right. Okay. We're going to get started again with our second speaker. Well, let's just make sure.
I'm here. Hopefully you can all hear me.
Yes. Do you mind sharing
Awesome.
your screen if you have slides on the
Yes.
Zoom?
All right. Can you see my screen?
No, not yet.
Mm.
One sec. Yeah. All right. We can see your slides. We can see you. Okay. Have at
Awesome.
it, Vito.
Thank you. All right. Hi, everyone. I'm Vito von Sastrov, and um, I'm a staff software engineer at Cisco. I've met some of you at the various conferences and meetups, and I'm very happy to be here giving you a preview of my RubyConf talk for Las Vegas later this year. And I am very happy to follow the previous talk, which was awesome and very relevant to some of what I'm going to touch. So I think these two go really well together. And hopefully I can answer some of the questions that came up. So let me get started. All right. So do your code bases contain patterns that you wish people would stop copying? Ours sure does. Our legacy code is full of characteristics and patterns that we don't want to see in new code. But because we have agents writing code, these agents emphasize the code base we have over the code base we wish we had. So it's as if our legacy code had gravity. And for context, this is a 5 million lines of code, giant Rails monolith. There's a lot of code there. It's 20 years old. So we saw, hard to test procedural code, non-performant queries, tests tightly coupled to implementation. AI was reproducing all of it faster than before. So when we introduced AI coding assistants, they truly increased the speed at which code was getting generated. It even wrote tests. So sometimes it was hard to get some people to write tests. AI was now doing it without complaining. And it was also faster to create a pull request and just put it up for review. But the agents were influenced by the surrounding code, so the pull requests were full of these patterns that we wanted to move away from. For example, our spec tests were stubbing way too much. Collaborators, queries, and even private methods. So yes, the test passed, but we could delete entire methods and the test would continue passing. We also saw this in controllers. AI preferred to replicate complex patterns like this from some of our largest and oldest controllers, and this is not even the largest one, into new controller actions. And now, this is all despite having clear instructions for agents. Those instructions were meant to guide the agents away from the patterns we no longer wanted and towards the patterns we prefer to see in new code. But the instructions were not followed consistently, and the agents themselves would admit, "You're absolutely right." They were just following the existing pattern. But that's not what we wanted. We wanted to improve the quality of our code, not reproduce the worst parts faster. And this problem was actually slowing us down. So yes, agents wrote the code faster, but because the code did not meet our quality standards on the first pass, reviewers spent longer reviewing commits, leaving feedback. And because these commits now received more feedback, it took longer to address this feedback. So writing code was faster, but shipping software was not. Now, this is what we want. We want to ship software faster and we want to improve the quality of our code base. So how can we get both? And before I dive into that, I need to address something. Some of you might be wondering, shouldn't the goal just be to ship software faster? Does code quality even matter anymore? Now, that question probably deserves a whole talk on its own. There is evidence, though, that LLMs trained on modular and readable, human readable code leads to actually better outcomes. There's studies out there. And if you don't believe me, you can just ask your coding agent of choice. Does code quality matter now that AI writes all the code? All right, well, if code quality still matters, and let's assume it does for now, then the real challenge is influencing what the agents are producing. So I want to share with you some techniques that we've actually found really helpful with guiding coding agents towards the code we want. These are using effective specifications, contextual guidance, and using skills as guardrails. Let's start with how to write specifications to get agents to follow instructions. Now, there's three practices here that significantly improve agent compliance. And by agent compliance, I mean not compliance in a security sense, but agents actually complying without instructions, following the instructions we're providing them. Let's take a look at how to apply persuasive language first. Now, there are 7 principles of persuasive language. This is a hot topic now with, artificial intelligence writing, like following instructions for us. And if any of you have used the superpowers skills, or I guess it's a plugin in Claude, that's how I was personally introduced to this concept. There's basically 7 principles: authority, commitment, scarcity, social proof, unity, reciprocity, and liking. Now, these are all ways to get somebody to do something, including agents. Now, when you're trying to enforce discipline in an agent, you should use authority, commitment, and social proof. They don't have to like you. They don't have to feel like they're getting something back from you. We want them to follow our guidance. Now, this is an example of how to use the authority principle. Do not, never, always. Please make sure that these rules are absolute. They are not preferences. This prevents agents from rationalizing around the requirements. For example, this helps in the case where agents go, and you can see this in Claude and in Codex as the agent is thinking, when they go, oh, this private method would be easier to test directly instead of following the instructions we have here. So you can use this authoritative language to get it to stop. But this alone is not enough. This needs to be complemented with commitment. Now, here's an example of how to use the commitment principle. Now, the evidence block here turns quality standards into an accountable workflow. This is going to create consistent pressure for the agent by making it harder to hide behind vague language. So rather than just saying, oh, yeah, like, I caught this regression. No, give me I need specific examples of these things. Now, there's one more principle that we need to look at. And this is the social proof principle. Here's an example of how we're using social proof to reinforce our repository's testing norm. So the norm here is that passing specs and high test coverage are not enough. The accepted testing standard is high signal tests and behavioral proof. So again, this puts pressure on the agent to follow instructions by making the desired behavior feel like the normal expected way everyone works in this repo. So it puts pressure on it to follow what everyone else is doing. Another technique that we found useful is always following structure planning. You want to always start by asking the agent to write a plan. And I heard somebody earlier say that that's how they start. They have a plan. That's great. You should leverage the agent's native planning mode when available. And you want to tell the agent the goal. You want to make sure that the approach it presents to you matches your expectations. But don't just take the first pass. adjust the plan as necessary. Read it, make sure it matches what you want, make sure it's actually trying to accomplish the goals, and then iterate with the agent on this. Now, when you're happy with the plan, save it to a file. This makes a huge difference. Like, don't rely on the agent's context to hold the plan. Context gets compacted and it drops important details. Agents are much more likely to follow a plan if it's written down somewhere durable. Now, you want to then use that plan to hold the agent accountable. Ask it to validate its work against the plan before presenting the code to you. Tell the agent to ask itself, does the list of modified files match the plan? Yes or no? Was every requirement in the plan addressed? Yes or no? If not, try again. Now, even with a great plan in place, there are other factors that are going to affect how well an agent follows instructions. Now, one of these factors is the reasoning effort. This is usually a setting, and what we found is that with low reasoning, agents tend to skip and merge steps more often. With high reasoning, it provides better results, but it's slower and more costly. And even with the highest available reasoning, we still don't get 100% compliance from agents. So you can use this as a lever. We found that medium reasoning is usually a good compromise for most tasks. And you can set the reasoning to high when you're taking on a complex refactor, or if you're backfilling tests for legacy code that nobody understands, it usually pays off to increase the reasoning. It's going to be a little bit slower, but it's going to be more likely to follow your instructions. Another factor that greatly improves the output is context isolation. Agents are a lot better at following instructions when they have limited context. They are more likely to improvise, and skip steps when they are in charge of writing the plan and then implementing the plan and then validating the plan. So if the same agent is doing it, it's going to cheat. Or it's going to rationalize that, oh, I don't need this test because, I already did this other thing over here. We've seen much better results when we use one agent to come up with a plan, a different one with a blank context to implement the plan, and then yet another one to also with a blank context to look at the implementation and validate it against that plan that we wrote to disk. Tools can also have an impact on context utilization. Now, we found that MCP servers introduce additional context overhead through their tool schemas, their capability descriptions, and the protocol metadata that the agent needs to understand and interpret. So this overhead reduces the context that's available for other things like writing a plan or implementing some code. We found that CLI tools tend to be more context efficient. These terminal commands tend to be compact and they match the patterns that these models were trained on. So we've observed that simpler CLI-based tooling leads to more consistent agent behavior over long-running tasks. All right, so those are 3 ways we found to influence agents to follow specifications more consistently. I'm gonna take a quick sip of water. So use persuasive language when you're writing instructions for agents. Follow structured planning and try to control the execution context. Now, another factor that we can leverage to improve the code that's generated by agents on the first pass is how we provide context about our system to these agents. So let's dive into how to provide contextual guidance. So there's 3 ways we found that we can provide guidance to agents and observe an improvement in the results. And these are an agents MD, architecture MD, and domain MD file. I'm sure all of you have one of these already in your project. But you want to use this agents MD file at the root of your project as a place that contains high-level instructions. You want to focus here on how to work effectively in your repository. Add a brief description on where things go, provide the agent with exact commands to run all the tests or lint all the files. And you can also guide it towards preferred patterns. But you don't want to, this comes at a cost. You want to be brief in this file. The cost is that this file is loaded at the start of every session and it will take up context. So keep the one at the root level short, and you can use nested agents files for sub-projects. For example, we have a JavaScript specific agentsmd file in the front end section of our code base. And obviously these files now that are nested should be focused on their area of the code base to avoid loading the agent with unnecessary context. Just a quick story, at some point we had all the linting rules for JavaScript and all the rules for working with Ruby at the top level. And now if somebody's just writing a React component, they don't need all the context about how to work with Rails or run all the RSpec tests. And yet the agent was loading all of that. Another lesson is don't use the top level file as a router. And this might be new in the age of AI, could be like a couple weeks or a month, right? But the agentsmd files are actually automatically read based on the area where the work is happening. So according to Codex and other coding assistance documentations, they will automatically find the nearest agentsmd file and load it for you. Now, it's also a good idea to use progressive disclosure here. And you want to do this to avoid loading unnecessary information in the context window when you're doing specific tasks. So instructions that are relevant only in certain cases should live in a separate document and be linked in the agentsmd file. You can see some examples here where it says additional guidance. Now, this is very important, but it also comes at its own cost. We discovered that agents can spend over 30 seconds loading reference files. So if a reference file is always going to be loaded, you might as well keep the content in the agentsmd file. If it's not going to always be loaded, then you do get the payoff of not having all that context in here. All right, so that's how agentsmd file can help tell the agent how to work in the system. But it's also important to provide the agent with an overview of the architecture of the project. Now, this file should define the structural and technical constraints of the system. It should describe the major components of the application. It should help answer the following questions for humans and agents. Where should code go? What layer owns this responsibility? What architectural patterns are preferred or forbidden here? Now, I'm not saying these are the patterns everyone should follow, but they should be your agreed upon patterns for your team. All right. Now, this defines the shape of the software. Now, the last piece here that's also important is to define the meaning behind these entities in our system. So you want to use a domain MD file to describe the core business concepts. Now, this file should include definitions for entities, business rules, workflows, and other concepts that are specific to your app. We're not talking Rails here. We're not talking about patterns. Think about what makes your app special. What problem are you solving? Now, if your domain is large, you can break this up into more focused domain MD files that live closer to the area of the system they describe. Okay, here's a table that you can use to remember what goes where. Agents in D teaches the agent how to work. Architecture in D teaches the agent how the system is built. And domain MD tells it how the business works. Now, these will give the agent the context they need to make better decisions. Um, but, having this contextual information is not enough. We also need a way to guide agents to perform specific tasks. And that's where skills come in. Now, there are 3 types of skills that we found are crucial to get, coding agents to write the code you want. The first one that I recommend highly to start with is a requirements skill. And this is not about coding, so it's one that tends to be forgotten, but it's actually very important. This skill takes a set of requirements and critiques them, offering suggestions to you. Now, the goal of this is not to generate code. The goal of this is to refine the requirements to remove ambiguity and get them ready for an agent to come up with an implementation plan. So this is not even the planning phase. This is something you might write back to your Jira or whatever ticketing system you're using. So again, the goal is to take the set of requirements and work with you, because the LM can't make this up. Somebody needs to decide what's going to get built. And so you need to capture that in a way here that removes ambiguity. The reason for this is that vague requirements are going to force the agent to improvise. They want to get the task done. If they don't have enough information, they're going to make stuff up. So this skill should ensure that the requirements include a clear goal, acceptance criteria, verification steps. How do I know that I did the thing? And I also recommend explicitly stating what's out of scope. This is really going to keep the agent focused. Now, once the requirements are clear, the next challenge is to make sure the implementation actually satisfies these requirements. And that's where testing skills come in. Now, without proper guidance, coding agents tend to write tests that are coupled to the implementation, or they use too much stubbing, or in my experience, they assert on configuration or features of the language. Just like our previous speaker was, talking about some examples. I've seen so many of these tests that they pass, and agents tend to optimize for the test passes. And even if you tell it, oh, give me good test coverage, it will optimize that number. And if you have tests in your legacy system that have undesirable patterns, the agents will be biased towards perpetuating those. And here's where a testing skill allows you to put strict guidelines in place for these coding agents. Now, you want to instruct the agent to focus on testing the business logic. Tell it to assert on the return values and observable side effects. Limit how much stubbing is allowed in your tests. And you can see here I'm applying the concepts we talked about before from persuasive language. Don't just tell it, oh, make sure what you did is good. Use this block of evidence and have it check its own work. And yeah, you might not agree with some of the guidance that I put here, but the point is that this skill should be opinionated, very opinionated, and it should be specific to your team's agreed best practices. Now, even with this persuasive language in place, agents still do not follow instructions consistently all the time. They're going to improvise and skip some of these rules, or they're going to still try and rationalize about what's strictly necessary to accomplish their goal. And we found that the most effective way to get agents to follow these skills, to comply with the instructions there, is to use sub-agents. This is similar to what I was talking about before with context isolation. You can have this skill be used by an agent and delegate work to sub-agents with isolated context. So what we do is we divide the work into implementation and review. One sub-agent receives the instructions to do the work, and the other sub-agent will take on the role of a reviewer. Both have access to the skill, so they know what they're doing, but only one of them is actually doing the implementation work, and the other one is only in charge of making sure that the produced test matches what's required in the skill. So the worker is only in charge of writing the tests, reporting results, and the reviewer is only in charge of judging the worker's results and then giving feedback. Now, this is going to create a cycle where the two sub-agents are iterating back and forth until the results actually match the criteria described in the skill. This is the only system that we've seen so far, because this technology is always evolving, right? That we've seen produce good tests on the first try. I was very surprised when he finally wrote a good RSpec test that looked like could have been written by a human. Um, Now, yes, that back and forth between the controllers, sorry, between the coordinator, the worker, and the reviewers, the various agents, might have taken longer than, if you had just prompted an agent and told it, hey, write me a test. But the results are much better. So this is that same test that it's being rewritten now using the skill. Now, these concepts definitely apply to tests, but beyond that, you can use this pattern to write implementation skills. Now, I recommend creating skills for very specific types of changes. If you make a skill too generic, agents are going to fill in the blanks with existing patterns in the surrounding code, or they're going to try to come up with their own interpretation. So we found that implementation skills are more useful when they are specific and narrow in scope. So this is a skill that provides guidelines for a controller action. So you want the skill to list out what should and what should not go in a controller action, for example. You want to follow those persuasive language techniques that I showed you before. And you should also leverage sub-agents to ensure that the instructions in the skill are followed. Now, these results are going to be much closer to your quality standards. Remember this controller I showed you before? I just gave the skills to an agent and told it, go divide the work among yourselves and follow this. And here's what it looks like after giving the agent the controller skill. I didn't write any code, just the skill. So skills and sub-agents may be a little bit slower than just prompting an agent, but they reduce rework, they reduce the review time, and they keep agents from reinforcing those patterns that we're trying to escape. So they really get us closer to that goal of shipping software faster and also improving the quality of our code base as we go. So there you go. There's 3 different classes of techniques to get agents to create the software you wish you had. Use effective specifications, provide contextual guidance, and use skills as guardrails. So if your legacy code is a black hole sucking coding agents into the patterns and characteristics that you no longer want to see in your new code, give this a try. They might just accelerate you to escape velocity and towards the code you wish you had. Thank you. I don't know. I hope we have time for questions. Yes. Well, I think the room is muted.
Can you hear me,
Yes, I can hear you now.
Adolfo?
Yes.
I'm really interested to know how you set up that situation where you had the 3 agents speaking to each other, orchestrator, reviewer, and the third one.
And the worker, I guess. Yeah. You just tell the agent to do it. Maybe I should add, that's great feedback. I should probably add an example of how the work coordination is set up. it depends on the coding agent you're using. They can all more or less figure it out. I think Claude has almost like a keyword that you can invoke and it will create a sub agent for you. But the skills we use at work literally just tell the orchestrator, you're an orchestrator, create a sub agent with new context, give it the skill, give it the work. And with Codex, you'll know that it's happening because Codex gives the sub agents, I guess, great thinkers names. So you'll start seeing Aristotle and other folks join your session and start to work with each other. But yeah, I'll make sure to add a slide with an example of how to get them to do that.
Thank you.
Thank you.
Hey, thank you for the talk. It was really cool to hear your experiences. When you were explaining the flow, essentially you go through specify skill and you have like the test writing skill and implementation skill. In my experience, one of the most value I get from like the commit and review skill that I create in the end, which goes through all the code, criticize it, and also based on the history of chat, kind of essentially discover what you were saying. Like, is there anything, any business rule or something that user said, and it can update the instructions based on that, if that makes sense. So you kind of create a feedback loop by that, like last step.
Yeah, and that's a great point. And in reality, there's like loops within loops, right? So you start with, let's say, a big plan to, implement something that's going to probably require multiple. Oops, sorry, my presentation is struggling. Let's say you start with something that's, you come up with a plan for a feature that's going to require more than just one class or more than just, a very small amount of code. And so what you'll do is you'll have your plan,
And
and then
plans never go fully like.
yeah,
Sure.
yeah, yeah. You start with your plan, you like adjust it, you use feedback, and then finally you're like, okay, this is what we want to write. And then where the like implementation and testing skills come in is as they are working on like very distinct parts of the work itself. So you're gonna use this testing skill to write a test file, and the implementation one to make a change to a particular controller. But at the end of that, you're still gonna end up with a pull request that you're gonna send out, and either you have feedback or somebody else has feedback, and you can then take that and incorporate it into your plan and start again. But the idea is that we want to shift the feedback about coding patterns as far left as possible so that you don't burden the reviewers with like, oh, here are all these things that we don't like to see in our tests or in our classes.
That's
Yeah.
that's what I was trying to say. Essentially, you see let's say the tests are mocked a lot, for example, and you
Right.
see that that's kind of like useless, and the agents love to mock stuff.
Yeah.
So you say that you see that and you instruct the agent not to mock that. But during the
Right.
review phase, the agent can take your feedback and incorporate it in the further instructions how to write tests. That was essentially, that's how my skills work, and that provided very useful because, you don't update your rules, and that kind of helps a lot. Anyway, like really good presentation. I learned a few cool things. So thank you very much for that.
Oh, no, yeah, thank you. I think I get your point. Like essentially have the skills improve themselves as you run into things you don't like. Is that?
Exactly.
Yes. Yeah. And that was definitely the process that we were using. And then eventually over time it kind of settles, right? Once you've found all the things that you're trying to avoid.
At one point you just say, do the work and everything
Yeah.
else happens.
Yep. That's correct.
Who's the next one?
I think it was Anton.
Oh, okay, I'll go this way.
Hi, Vito. Thanks for your talk. And one
Hello.
thing that caught my attention was about your idea of saving the plan into a separate source to be sure that this context wouldn't be affected in the future. And it felt that it might be quite an interesting approach. And I wanted to ask you whether that's an isolated approach for the specific case, or like, do you use it in other situations as well? Because it felt that if you dig into it, there might be quite interesting patterns of working with AI overall.
Yeah. No, there's definitely other applications as well. For example, um, you know what? Sometimes you're just doing research before you actually get to build something, and you're working with the AI. You generate some like artifact of your research, and it might be helpful for somebody else reviewing the code later. Now, checking it into the code base is something that has come up internally. Like, should we, actually have these generated documents coexist with the code? And honestly, like they feel like they're too temporal. Like they make sense at the time when you're doing that work. Over time, they might not make sense, depending on, what's in the document. A good compromise is if you have let's say a Jira ticket. We use Jira at work. If you have a Jira ticket, and you generated a plan or you did an analysis of a particular feature, you might want to, attach it to the ticket or post it as a comment. Or maybe you want to post it, Alan, I think said in the chat there. In some cases, it makes sense to, store it as a comment on the pull request.
Okay, thank you.
Okay. If you don't get the results that you expect from the skills, how do you know whether it was the skill being ignored or the skill never being invoked?
There's a few ways. You can tell when it's invoking the skill if you look at the logs, but that can be depending on like what's happening. You might miss it. You can ask the agent, "Wait, did you use the skill?" And sometimes they'll say, "No, I should have. You're right. I'm sorry." And then you can work with the agent on like what would get you to use this skill, because sometimes there's a front matter to every skill that's is all that the agents load up front, so they know when to invoke the skill. So it might be that the description was not broad enough to capture the use case you're working on right now, or it might be that the agent decided it wasn't worth the context to load your skill. I know a better way. I'm just gonna do it. It's been challenging. So if you use Cursor, or if you use Claude, there's like various hooks that you can use. And for a while, they were giving us better compliance in terms of like actually using the skill. Over time, they became less useful for that. Like as agents get smarter, they really want to improvise and optimize the work you're giving them. And so they find a way to rationalize to not use the skill. You can invoke the skill directly. I think with Cursor, you can do slash and then the name of the skill, and it will use it. So it's the technology keeps evolving around, how to invoke the skills. The ideal world, if you don't have to explicitly remember, oh, I have a skill for that. It just knows based on what you're doing, but it's not 100% there yet. Oh, one more thing. We use evals. So we write basically. Are you all familiar with evals for? Yeah. All right. So they're basically tests for your skills and for your agents. And so you can have an eval where you specify when I write this prompt, the agent should use this skill and this should be the output. and it allows you to write various different prompts and kind of like test what works and what actually gets the skill to be loaded and what doesn't. It also allows you, it's how we determine that, the loading all the references in the agents in view can take up to 30 seconds. It's also how we measure the effects of the reasoning effort on a task. We have a mock repository with all these reference files and with skills, and we're basically kicking off an agent headless and telling it, okay, go read the skills. Here's a fake Jira ticket. Go implement it, and then we can see like how compliant it is or not, and then we can tweak like the reasoning effort. Was that faster? Was it more compliant? And you can also measure tokens and all that to see if it's becoming too expensive to get compliant code, which is a whole other topic.
Oh, thank you, Vito.
Thank you
All
all.
right. Okay. We're going to take a really quick bathroom break and then we'll close it out strong with Noel. Yeah. Maybe like 5 minutes.
Yes.
How are we doing? Ready? Sorta, maybe. I should just stand here and have it look like it's being given by an empty chair. First of all, thank you all for coming tonight. I also wanted to especially thank the Chime Workplace crew and the people who have stayed here from Chime, who have made this very possible. Thank you so much. Very much appreciate it. Other than that, welcome here. So I'm also going to be talking a little bit about AI and Ruby. It seems like that's what we all talk about now. I'm focusing in very hyper specifically on something very specific that I did that I thought was weird. I think one of the things that we have kind of alluded to in both of the previous talks is just how weird it can be to work with these tools at the moment, how they can feign intelligence so well for so long, and then you fall down the cliff of how actually unintelligent they are, and it's jarring. And like I had Claude fed me a word, an English word that didn't exist yesterday, and said it was a typo. I don't know how that works. Like all of this is very strange. We want to talk about one particular little adventure that I had. So this started with a terrific idea in the sense of Terry Pratchett, terrific and terrifying. So this is Inspector Gadget. I'm calling this Adventures in Agent Code Review. I'm Noel Rappin. I work here at Chime, not here at Chime. I work in my home about 20 miles north of here, but I come here every now and then for the snacks. So I have this weird belief that code quality is still important. Vito mentioned this briefly. My weird hot take at the moment is that eventually what makes code valuable or easy for the robots to modify is going to wind up being more similar to what makes code easy for humans to modify than we kind of think. That's kind of by the way. The point here is that because code quality is important, and as has been mentioned, LLMs do much better when you ask them to do a code review. When you even push back on them slightly, even if you just ask them to like look at what they have done and gaze upon it. So I've spent a lot of time in the last couple months trying to improve code review, trying to improve the quality of the automated code review that I get from the LLMs, trying to improve the quality of the prompt, trying to improve the quality of the setup. Basically, I want me, the human, to be in at the highest possible level. And so one day, on a weird whim, I typed in, look at this diff. What would Sandy Metz do? Weirdly, I got something back. I did not actually get what Sandy Metz would do because that would be insane. But Sandy Metz, like in the training set here, presumably has a lot of detail that talks about Sandy Metz, author of Practical Object-Oriented Development in Ruby and 99 Bottles of OOP. There's enough people who write about Sandy's rules and Sandy's output that the LLM had a pretty clear idea of what it meant, what I meant when I said, what would Sandy Metz do? And so I didn't get exactly what Sandy would do, although I do hope that Sandy's doing really well in the Anthropic settlement, because boy, this was a little bit weird. What I actually got though, I got Claude to comment on its own factoring in a way that I had not gotten it to comment before. It actually did say things like, oh, this is a God object, or oh, there's feature envy here, or this method is too big, or this method is too complicated. I don't remember the exact details. What I do remember was that I was getting an entirely different focus of review than I had gotten before. So being me, I went a little overboard. From there, I was like, oh, cool. Like, what can you do? Who else? Who else does this work for? So I created a bunch of things. Basically, what I created was a multiple agent review process where every agent had a specific focus and a specific voice. The focus was because I was coming to believe, and I have come to believe, that LLMs do much better when you ask them to do very, very specific things. Even if they're sort of vaguely defined, asking an LLM to do review this code is nowhere near as good as saying, look at this code for this specific set of style variations. So that involved doing multiple agents. I originally asked them to give them all a different voice for my own entertainment and also just to kind of see what would happen. So I had a what would Russ Olson, author of Eloquent Ruby, do that was owning Ruby style, Ruby idiomatic Ruby style. I had what would Dave Thomas do that owned the Ruby standard library if it was doing something that was already an existing Ruby standard library method. Nate Berkopak, performance. Is there something here that is a performance violation? Justin Searles for testing. Justin, the testing agent, interestingly, we've been talking about testing. The thing that I had the testing agent do was basically two things, one of which was look at every test. Does the test do what it says it's doing? And also, you, the agent, believe testing is a positive good for creating good code in the future. And actually, that agent came back with a ton of stuff that none of the other agents did, and it was mostly pretty high quality. I had a couple that I didn't give actual names. I had a security expert. There was also a bug bot. I think I told the bug bot, you are embarrassed if the cursor bug bot finds something you don't. Plus, I also typed up manual notes. So then I had an orchestrator that looked through my manual notes and looked through all of these and came up with a list of stuff to do. So yeah, I ran them as agents with an orchestrator. It did feel creepy. It does feel creepy. I own that. It actually did. It worked for some sense of worked. It certainly found and surfaced a ton of issues, like dozens and dozens of issues. And mostly high quality, sometimes picky, but generally like was improving the quality of the code. Eventually, where this got really weird is after I did this 3, 4, 5 times, as Fito was mentioning, I also got in the habit of having all of this stuff get spit out to markdown files for compactness reasons. One of the other reasons to do that is that you can then audit it. So after I had 4 or 5 little subdirectories with all of these notes, I said, hey, we've done this a bunch of times. Is there stuff the agents are missing? Are the agents actually finding distinct things? Like just generally, like look at this and tell me if this breakdown makes sense. And what the LLM came back to me with was, it said the most impactful changes have come from the user. And the most impactful changes have been, this is too complicated. We don't need to do this at all. It said, you should have an agent that should check for simplicity. And then it said, that agent should be named Kent Beck. And that was genuinely disturbing. And genuinely a little bit strange, but Kent Beck, somewhat famously in the original XP book and in other places in test-driven development, talks about designing the simplest thing that could possibly work. It makes perfect sense. It was also a little bit weird. So that was kind of a yikes moment for me in terms of this. Like, is this actually, like, what is actually going on here? So the positive of this is that it found a lot of stuff, and in particular the test agent did, and I've continued to use the testing agent, is extremely token expensive. Like each of these agents would, and I tried a bunch of different things, and I tried a bunch of different things that the LLM insisted would lower the token cost and didn't, because the LLM knows that it is paid in tokens, presumably. And I do think though that it is inherently a problem with code review. It is sort of inherently token expensive. And I'm not entirely sure everything that I've tried to do to work around that has resulted in poorer quality reviews. In particular, once the LLM came back to me after like a review where it didn't find much, it came back to me and the LLM said, oh, I just skimmed the code. It's like, look, I can skim the code. Like, this is not your role here. Your role is to focus. So when I use less tokens, it always somehow resolves into having less review. Eventually, though, what happened is what I tried to do is use this audit process to do a continual improvement of the agents. And as the part of every review process, it also had a step where it said, hey, the stuff that it didn't find that the user found, is there a way to incorporate that into an agent? Which seemed to make sense in terms of like continually improving the agent performance. But what happened is the agent prompts got to a point where they got complicated enough that there was a certain little bit amount of model collapse, that it was no longer, it got to the point where it was no longer able to focus on the specific thing that I wanted to focus on, because I was giving it like 7 or 8 examples of things to look out for. And that happened quite quickly. And I never quite got them back to the state that they were actually, that I thought was sort of peak. And so one of the consequences of that was they were losing their unique voice when they were describing stuff. They were finding more duplicate stuff because they were all looking for the same things. The like stay in your lane part of the reviews got lost. So that's a little bit weird. It's kind of counterintuitive that in this attempt to continually improve the agents, their performance actually got significantly worse. So to answer the other question, there was a Noel Rappin agent, because I felt like if I was going to do this to all these other people, I had to do it to myself, which by the way was really weird because the orchestrator would come back and the orchestrator knew me as user, but it knew the Noel Rappin agent as Noel Rappin. So it would come back and say, well, Noel Rappin and the user agree on this. I was like, very weird. The Noel Rappin agent in this context, since I made Dave the owner of the Ruby Standard Library, the Noel Rappin agent in this context was the owner of Codebase Standards. It's primarily my code base. So the Noel Rappin agent was like, you are in charge of making sure this code is consistent with other things in the code base. Look here for some common abstractions that you may not be using that you should be using that are specific to this code base. That kind of thing actually was also very effective, not necessarily the Noel Rappin agent. But the one thing I do want to share with you, so it's the owner of Codebase Standards. The one thing I do want to share with you is one of the things I told it about my unique voice is I told it every finding should have a title that was a pun, a Muppet reference, or a sports analogy. Again, mostly for my own amusement because I was curious. So in case you are even the slightest bit curious, here are some of the things I got back. It's a very small sample of what wound up being kind of a rich text. The Swedish chef is still calling the gems gem locations. Who left the script notes from the old production? Don't know what that means exactly. I got, it's like Beaker trying to order a Coca-Cola when the sign says Pepsi. Sure, fine. I got what I think is, I got Stadler and Waldorf in the box. .getpath is narrating from the balcony with nobody listening. This has the format of something that makes sense, but it doesn't actually make sense. And my personal favorite was don't re-implement the arm wave the puppet next to you is already doing. Sure, fine, I guess. So the next thing I tried, and I said I would be quick, and I'm going to be quick. I just want to quickly say where I went from this and where I am kind of experimenting right now. Ruby has sort of this rich set of static tools, static analysis tools that were very popular like 10 years ago, and I haven't really seen much about them recently. So I'm talking about things like FLAY, which is duplication analysis tool. These are all from the Seattle Ruby group, which is why they have weird names. There's FLOG, which is the complexity score metric, and REEK, which is a general like code smell that is somewhat like a more stylistic friendly Rubocop. And I have been using these as a front end to the analysis. In particular, FLAY, which is the duplication analyzer. One of the things that I think is a particular weakness of the LLMs is they are not very good at detecting duplication that is not in their immediate context. So one of the great things about FLAY is that FLAY does an abstract syntax tree analysis of the entire code base and tells you where the most substantial duplications are across the code base. And that costs 0 tokens because it is an automated tool. And then you can say to the LLM, look at the output of FLAY. Tell me what I should do. Like, let's evaluate these heavy duplications one by one. And that is significantly less token intensive. And it also solves a problem that I was having with the LLM code, was that it was building up a lot of duplications. I've had a little bit less success, but some success with FLOG and REEK and another tool called Churn, which is just like the standard complexity score is like, what are the most complicated file? The standard measure of how you choose to refactor a file is how complicated the file is, plus how often it's touched. So you can use flog and churn together, again, to produce a static report. And you can then send that static report to the LLM to fix the issues rather than having the LLM try to come up with all of the issues itself and to try to fix them. There's a place for both of them, but like I created a skill called air freshener, which like runs reek, flay, flog, runs all of these and comes up with a score like for what the most complicated, for what the worst files in the code base are, what the most files most in need of change, and then passed it to the LLM to like talk to me about what to do about LLM. And that actually produced a pretty high quality set of review. I haven't done it a whole lot. I haven't done that a whole lot of times yet. I just started doing it, but it's really promising to me. So I'm really liking this combination of static tooling, static analysis tooling, and LLM. So a couple things, some of these have already been said. Produce a lot of design documents. In particular, then they're always available where you know they're available, and you can always tell the LLM to pull them into context. And you're not at the whims of when the LLM chooses to pull them into context. And again, you can then go back and audit them and talk about them as a collection, which you can only do if you are in control of them. I encourage you to experiment with stuff like this. Like, nobody really knows what works yet. These tools have been in our lives for under a year for most of us. That's not a lot of time. One thing I say a lot is nobody really knows what the long-term effects of using this are on a code base. And I don't mean that to think that they're going to give you some sort of dread disease or anything like that. I mean that we literally don't know what happens when we build code on LLM code on top of LLM code on top of LLM code for more than 6 months. Like the number of code bases that can say that they have experience in that is like very small. It's going to get a lot bigger in the next 6 months. We don't really know. Try things out. We are just, I think, coming to the end of the era in this tooling where it is like great to just experiment with stuff. Audit, try to improve your stuff. Be careful about the sort of model context collapse kind of thing. But definitely try to do continuous improvement on your own work. LLMs, because of the way that LLMs build up context, they're like, they are all both very good and a little bit counterintuitive in terms of being able to continually improve their performance. But if you see something that the LLM is doing that you think is a bad idea, like the point is to try and write that down so that it won't do it in the future. So that's what I got. So thank you all for coming out here. I think we have the room for another, I don't know, 5 minutes at least. And also for the extremely large modern day market for 700-page programming books, the Pickaxe book, volume 6, which covers Ruby 4, is available in ebook at Prog. It will be available on Amazon as a paper book soon. I'm told there's a hiccup in the production process. It's getting there. Also, if this made sense to you and you thought, oh, I want to see more stuff that person does, noelrappin.com has a bunch of stuff, videos, blog posts, there's a newsletter. Who knows? That's where most of my stuff goes online. And that's it. Thank you for paying attention. I'm not sure whether this lends itself to questions, but if people have questions, I'll just walk around. We don't need to sit over through it. Thank you very much. Thank you to the Workplace team. We really appreciate it.